friends, in this video we will discuss about numerical problem based on matrix chain multiplication. Inputs may be given in terms of dimension vectors or the size of individual matrices. Let us see dimension vector D is equal to 10, 100, 5, 50. From dimension vectors you can find out size of the matrices and how many matrices will be there. First matrix A1 and size is 10 by 100. A2 matrix and size is 100 by 5. Third matrix A3 and size is 5 by 50. So in this way we have got 3 matrices from the given dimension vectors, means number of matrices n is equal to 3. Now once we have got number of matrices and their size, so we have to specify the structure of two tables, M table and the S table. Now here in a M table, J starts from 1 to N. This N is nothing but number of matrices, and I starts from 1 to N. N is nothing but number of matrices. Now once we have specified the structure of M tables, we have to specify the structure of S table, and in the S table J varies from 2 to N and I varies from 1 to 2. Now in S tables, so a bigger diagonal is removed. First we have to fill up the M table, corresponding to that we have to fill up S table. In M tables, so there are diagonals. First diagonal is S is equal to 0, S is equal to 1, S is equal to 2. In S is equal to 0, there are 3 cells. S is equal to 1, there are 2 cells. S is equal to 2, there is 1 cell. Now we will start from S is equal to 0. For S is equal to 0, we have the first formula. For S is equal to 1, we have second formula. For S is equal to greater than and equal to 2, we have third formula. Now let us start from S is equal to 0. For S is equal to 0, we have the formula. For I varies from 1 to N minus S. Now here N is 3 and S is 0 is equal to 3. So for I is equal to 1 to 3, you will get 3 cells for S is equal to 0. For I is equal to 1, we have instruction M of 1 comma 1 is equal to 0. For I is equal to 2, we have 2 comma 2. 2 is nothing but value of I, that is 0. For I is equal to 3, put I is equal to 3. 3 comma 3 is equal to 0. Now M of 1 1 put 0, M of 2 2 put 0, M of 3 3 put 0 in M tables. So this is 1 1 put 0, this is 2 2 write 0, this is 3 3 write 0. Now this is for S is equal to 0, means diagonal S is equal to 0. Now next diagonal is S is equal to 1. For I varies from 1 to n minus s, So we know the value of n, that is 3, and s is 1, is equal to 2. Means I varies from 1 to 2. If you see here, for s is equal to 1, there are 2 cells. Now for s is equal to 1, we have to use the second formula. For I is equal to 1, m of I comma I plus 1 means 1 comma 1 plus 1, that is 2, is equal to di minus 1 means d0, di means d1, then di plus 1 means d2. Put the values, is equal to, so you will get the values of d0, d1, d2, d3 from dimension vector which is given as a input. Now this is nothing but d0, this is d1, this is d2, and this is d3. From this you can take the values of d0, d1, d2 and d3. So value of d0 is 10, value of d1 is 100, value of d2 is 5, is equal to 5000. Then take next value of I, that is I is equal to 2. For I is equal to 2, m of value of I is 2, then I plus 1, 2 plus 1 is 3, is equal to di minus 1 means d1, di is d2, then di plus 1 means d3. Put the values, d1 is 100, d2 is 5 and d3 is 50. It comes to 25,000. Now then, m of 1 2, on m of 1 2 put 5000, 1 2, that is 5000, and m of 2 3, that is 25,000. m of 2 3 is 25,000. Now once we have obtained the values for s is equal to 1, we have to put the values in s table. Now see here, 5000 we have got for I is equal to 1, means put I is equal to 1 at 1 2 place in s table. We have the 1 2 2 place, this one, and value of I is 1, put here 1. Similar way, we have got 25,000 and we have put 25,000 at m of 2 3 here. Now at the same place in s tables, we have to put the value of I for which we have got 25,000 and value is 2. I is equal to 2. Now in this way we have completed s is equal to 1. Then go for s is equal to 2. For s is equal to 2, we have to use third formula. For I is equal to 1 to n minus s. For I is equal to 1 to n minus s. Here value of n is 3 and value of s is 2 is equal to 1. You will get the one cell for s is equal to 2. Means I varies from 1 to 1. For I is equal to 1, m of I that is 1, comma I plus s. So I is 1 and s is 2. 1 plus 2 that is 3. 1 3. 1 3 cell. Minimum value of I is 1 less than equal to k less than, here is less than, I plus 1 means 1 plus 2. Value of I is 1 and value of s is 2. 1 plus 2 that is 3. Means case varies from 1 to 2. K varies from 1 to 2. So you will get two values. One for k is equal to 1, another for k is equal to 2. First take k is equal to 1. M of I comma k means 1 comma 1. 1 comma 1 plus M of k plus 1. K is 1, 1 plus 1 that is 2, comma I plus s. I plus s is nothing but 3, plus di minus 1. I is 1, 1 minus 1 that is 0, d0, into dk, k is 1, d1, into di plus s. I plus s is nothing but 3, so d3. So put the values. M11 you will get the value from M table. M11 that is 0. M23 that is 25,000 plus D0. D0 is 10, D1 100, D3 50 is equal to 25,000 plus 50,000, it comes to 75,000. Now this is for k is equal to 1. You will get the next value for k is equal to 2. For k is equal to 2, use the same formula. M of I comma k, value of I is 1, k is 2, plus M of k plus 1, I plus s, k is 2, 2 plus 1, 3, I plus s is 3, plus di minus 1 means d0 into dk, k is 2, into di plus s, so I plus s is 3 means d3. Put the values. M12 122 5000 plus M33 is 0 plus D0, we have D0 10, D2 is 5, D3 that is 50 is equal to 5000 plus 2500 is equal to 7500. So we have got two values. For k is equal to 1, it is 75,000. For k is equal to 2, it is 7500. Out of these two values, 7500 is minimum value. Take this value for M of 13 and put in the M table, that is 7500 and we have got 7500 for k is equal to 2. We have got 7500 for k is equal to 2. Put k is equal to 2 at 1 3 place in S table. So 1 3 place is this one and value will be 2 because at k is equal to 2 we have got the minimum value, that is 2. In this way we have obtained M table and S table. And to get the optimal parenthesization we have to refer the S table. In M tables these values gives us the minimum number of multiplication operations the required. Now next step is to get the optimal parenthesizations. For the optimal parenthesizations we have to refer the S tables. From the S tables we will try to draw tree structures. Now in this we have to start from cell 1 3. S of 1 comma n, so value of n is 3. So from this show two children's, left child and the right child. Now here is S 1 comma dash and here is dash comma 3. Find out which value is on 1 3 in S table. 1 3 it is 2. So that's why I write here 2. Add 1 to this 2 to get the value of the right child. 2 plus 1 means 3. Then again S of 1 2 can be grow with left and the right child. 1 to 2 we have the cell here. S of 1 comma dash, here S of dash comma 2. Add S of 1 2 we have 1, so write here 1 and add 1 to this one, so you will get 2 here, 2. Now then S of 1 1 is there. S11 cell, S11 cell is not there, so that's why, so you have to stop the growing this side and write here A J, that is 1, A1. Similar way S of 2 comma 2, see here S of 2 2 cell is not there, so write here A2. Similar way S of 3 3, check in the S table, S of 3 3 is there, S of 3 3 is not there, so directly stop here with A3. Then in the second level enclose this using parenthesis, opening and closing. Similar way for this also specify the opening and closing parenthesis. Now then from these structures, so write down optimal parenthesization. Optimal parenthesization is equal to, start from down to upside. Now here we have A1. A1 is multiplied with A2. A1 and A2 are enclosed using opening and curly bracket. Then consider the same bracket here, same as it is. So before that, so there is opening bracket, and after this, so there is A3 into A3, and after A3, so there is closing bracket. So in this way we have got optimal parenthesizations, that is in bracket A1 A2, complete the bracket into A3 means we have to multiply A1 with A2 and the result of this will be multiplied with the A3. And for this optimal parenthesizations, the minimum number of multiplication operations required will be 7500. So in this way, we have solved the numerical problems based on matrix chain multiplication. In next video, so we will discuss another problem based on matrix chain multiplication. Thank you.